Hello everyone. Let's start solving this question. Find all possible stable binary arrays. 1. So you are given three positive integers 0, 1 and limit. A binary array ARR is called stable if number of occurrences of 0 in that array is exactly 0. This is not 0, this is a integer 0 that the value can be 3, 4 or anything. Okay, till I think the constraint is 200. Yeah. Now, and number of occurrences of 1 in ARR is exactly 1, and each subarray of ARR with size greater than limit must contain both 0 and 1, and we have to return the total number of stable binary arrays. Okay, now let's see what is given is first what number of we will be given 0, 1 and limit. So array will be what? It will be those many zeros. This is let's say for example this is x, this is y, this is z. So my array will be x plus y. Array size will be x plus y. Okay, and this will contain, this is only binary arrays. Okay, this will be binary array as we have only 0 and 1. Now what is limit? So first is my array will contain these many zeros and these many ones. Okay, let's say my x is 2, my x is 2 and my y is 3. That then we will get this binary array. Now my limit is z. What is given? The third, what is the third condition given is each subarray of ARR with size greater than limit must contain both 0 and 1. Okay, now let's understand what it is given, that each subarray. Okay, here let's say consider this array. So each subarray, so you know what is subarray. This each subarray which is greater than the size of this limit. Let's say my limit is 2, then my subarray should be of size greater than 2. Here it is written, if you see, greater than, not equal to. So my I will check, let's say my limit is 2, I will check what? I'll check the subarray with size with size 3. Okay. Now let's say this is one subarray. Now we have 1 0 1, we have 0 1 1. Okay, now these three subarrays we got with limit greater than 2. Okay, now it should contain both zeros and 1. This contains yes, yes, yes. Okay, so those are many. This is for this array. Okay, this is for this array. There will be different possibilities of constructing a binary string. Let's say I can have 0 0 1 1 1. Okay, I can have, for this is a stable array. Then now for this case, is this stable? Now let's see, 0 0 1 0 1 1 and 1 1 1. Now is this sub array contains, does this sub array contains both 0 and 1? Yes, this yes, here no. So this is not a stable array. So we have to return the stable array, total number of stable binary arrays. So you have to understand that this each subarray of ARR with size greater than limit must contain both 0 and 1. So for that, what we understood is what my array should not contain consecutive 0 or 1. How many times? Limit, greater than limit. Okay, if it is greater than limit, not equal to, okay, only greater than limit, then I can say this is not a stable. So what we can say is if my array has consecutive zeros or ones, how many times? At limit, maximum at limit. So my 0 here, in this case, my 0 can be once, my 0 can come twice consecutively, but my 1 can come 1 and only this, because my limit is 2. Till I can't take this in my array. Okay, so if I have 0, if I start with 0, let's say I start with 0, next I will add 1. So what option I have? 1 or 1 1. Now after 1, what we can add? We can add 0 and 0 0. Why only 2 times? Because till limit is 2. If my limit is 3, I can have 0 0 0 0, again triple 0. After this also we have option 0 or 0 0. Okay. Now in this way we will be finally building our binary string. Okay, binary array. So if you understand this, so I'll again explain. What I did here is, we can take, okay, we have to return what number of stable arrays. So we have to understand how to build a stable array. How we can build stable array is considering from length 1 to limit. Okay, my length 1 to limit I can take consecutively. So I can take 0 twice if my limit, let's say my limit is 4. I can take 0 as 0 3 times, I can take 0 as 4 times. Yes, of course, we will be considering this variable, okay, 0, number of zeros. If my number of zeros are only 3, but my limit is 4, so we will consider 3. Okay, so we will consider minimum of zeros or 1 comma limit. Okay, this, so if I consider this, what all option I have is, after this I have to append only 1. Okay, I mean 1. It can be single, it can be double, it can be triple, based on the limit and number of ones. Now after this also I can, like this we will be generating a binary arrays. Now this is a recursion problem, so we will be optimizing it to memoization. First let's solve this. So how we will write the recursive code? Okay, so what we will do is, we need number of zeros, number of ones. Of course we can't go like infinity times. Till when we will stop this? When my number of zeros and number of ones are 0. Let's say initially those are 2 and 3. After adding, okay, I got 0, then I will reduce 1, then I have 1, I'll reduce 1 from here. I have 0, I'll reduce from, so 2 zeros are done. Now 1, again I can't add 0, so I will be adding only 1. Yes. Now, so if my, so there will be different cases. Okay, if my both this, let's say we will take zeros left and ones left. How many left? Okay, if both are 0, then we can stop this. Okay, then we got a stable binary string. We can consider this. Yeah. Now what we have to pass? This one, this we need limit, and what we need an indicator for what? For what was the previous state? Was the previous state was 0, then we have to consider now 1. Was the previous state was 1, then we have to consider 0. Okay, now we need a boolean, let's say was 1 last. And then what we will do is, first that will be the base condition, then based on this was 1 last, if it is true, then we will consider 0. So now I will add zeros from single 0 from length 1 to length is equal to minimum of zeros left comma limit. Okay, till that point we will call the recursive function, and like for this we will call again, for this we will call, like that. Okay, so for next this call. Okay, after this, so this way we will be using recursion. Yeah, we are going to optimize it. Yes, stay updated. Now let's write the code. So let's write public int, let's say solve. Here what we will take? Int zeros left, int ones left, int limit, and boolean was 1 last. So what will do if my um, zeros left is equal to 0, and if my ones left is equal to 0, both are 0, that means our first two condition satisfies. We will return 1. So this is the one stable array, binary array. Now next what we will check, if my was 1 last. Okay, if it is true, we will consider what, we will consider 0, else we will consider 1 to append. Okay, and at then we will return one answer, or I'll use a result. Here I will use int result, or let's take long for now, long, because the answer can be maximum, right? Long result. Okay, initially it is 0. Here what we will do is, if we have to add 0, from when to when, from length. Okay, I'll take for int I is equal to 1, from length 1 to length less than or equal to mat dot minimum of limit comma what, this is for 0, so 0 is left I plus plus. Yes, now what we will do, result is equal to result plus what, again same recursion call with what, we have added 0, how many, how much, like I. So initially we will add 1, then 2, then 3, till this limit. Okay, so what we'll do, my here I'm passing zeros left, right? So what I'll do, zeros left minus I comma, ones left will be all will be remaining, we are not using, and limit, and here what we'll do, here false. So was 1 last, no, this was 0, so false. Now same thing here for 1, here it will be ones left. Okay, and yes, so this will be our result. Let's take a mod long 4 5 6 7 8, and this 10 raised to 9. Okay, and here we will use a mod percent mod. Yeah, we are going to convert this to memoization, so stay updated. Here what we'll do, here we will return what, solve. See, what we will return is, this is to solve if my was 1 last. Okay, so from 0 or 1, but initially we have to start with both, so I will first start with 0 and then I'll start with 1. Okay, so in that case my 0 and my count will be the same, only I'll pass the boolean value different. So here I'll pass 0 1 limit and initially false. Let's say we have started with 0 considering, and plus solve 0 1 limit and true. Now percent mod, and we have to convert this to int because we are returning the int, right? Now let's run this. So of course this will give us TLE for some cases. Okay, let's check what's wrong here. What we did wrong, anything, maybe something. Yes, here we should pass true. Yeah, let me run this. So I have taken some examples where it can get TLE. Okay, yes, so you can see time limit exceeded. So normally you will not see in your test cases, because when I ran this before I got this, so just to show you I kept in my test cases. So for this case we got TLE. Okay, Of course, this is repetitive. So how we can optimize this? Let's use memoization. So how we can use that? So considering zeros left and ones left and was one last. So can we do this? Like for example, I have two two zeros left and one left. Okay. Not in this example. Consider I have two zeros and one left. Okay, two zeros and one left, and initially it was true. Same case if I get again that I have two zeros, one ones, and it is true before. So why do I need to recalculate this? Why can't I use the same thing if I get stable string or not? So in that case we can use memoization. We have to store the result and use it again. So how we will do is, let's see. So what I'll do, I'll use a array. Let's use long. Let's say dp. Why three times? Okay, because one will be zero, one will be for one, and also we have to consider the was one last. This true or false. So consider zero for zero and one for one. Okay. Now what we will do? Let's initialize it first. So dp is equal to new int. It will be 0 plus 1, 1 plus 1, and two sides. Okay, let's initialize with minus 1 for everything. So for long, it should be long, let's say a, and this will be dp for long b of a. Okay, for each one. Now what we'll do, arrays dot fill minus 1. Not sure, I have to check this. Let's check. Oh, in Java, if you're not sure about the, you can check. See, I got confused. It is fill, not fill any. I went to some different library. Okay. Yes, it is fill. Correct. Now minus one. Okay. Now here what we will do is before checking. Okay. Before checking, like before going to this, what I'll do is here I'll check if my dp of zeros left, ones left, and 0, if it is not equal to minus 1, that means the for this we have already computed, okay, the result. So what I will do, we will return the same. Else else what I'll do, I'll compute the result and I'll store that in this. Same thing we have to do, same for this. Here 1 and 1 is equal to result. That's it. Yes. Now let's run. Yeah, you can see accepted. Now let's submit the solution. What we did is we just stored the computed value, okay, and again checked if it is already computed for this case.